Hey everybody, your Friendly Math Tutor here with episode 4 of our SAT Prep mini course. So each week we're going to dissect a strategy that you can use on your upcoming SAT. This episode, before we get to that, let's go over the closer problem from episode 3. All right. So this is College Board Practice Test 7, Section 4, number 17. Starts out with an equation, y equals $19.99 plus $1.50x. And it says the equation above models the total cost y in dollars that a company charges a customer to rent a truck for one day and drive the truck X miles. The total cost consists of a flat fee plus a charge per mile driven. When the equation is graphed in the XY plane, what does the y-intercept of the graph represent in terms of the model? So this is another one where, again, I'm just reading it just to to show how long that takes, all right? So on a timed test such as the SAT, we want to be able to do these problems as quickly as possible, so we need to take a little bit of shortcuts, all right? So just to recap from last week, we just need to look for some keywords and understand the different positions that we can have when things are in slope-intercept form. So the reality is when you look at this problem, as soon as you see it in slope-intercept form, you really don't need to read the problem. All you have to do is kind of skip to the end and look, and they're looking for the meaning of the y-intercept, which this is in the form, this is kind of in the form y equals mx plus b, but they just have it switched. So they've got $19.99 plus $1.50x. You may be used to saying it in this way, $1.50x plus $19.99. And the $1.50 would be in the position where, if we look at y equals mx plus b, m is the slope, that would be $1.50. So they're not talking about in this problem. All they're talking about is the y-intercept, which is b, and that's $19.99. So we know that they're talking about $19.99. That eliminates B and C B and D, because B is $1.50 and D is $21.49. So now we're down to A and C. And if we look at a flat fee, well, we did mention that last week on our keywords, but even if you forgot that, C is a charge per mile. So we really need to understand that when you see the word per, that is a rate, and a rate is associated with slope. So that would have been the $1.50. So just by process of elimination, it has to be a flat fee of $19.99. All right. Also, a flat fee. So we talked about in general what the y-intercept is. It's when the x, or the input, is 0. So that's exactly what a flat fee is. So if you look at the context of this problem, even though you don't need to read it, but since we already did read it, and to use it as an example, we're talking about a moving company. They're charging you per mile driven. So the flat fee is going to be what you're charged before there's any driving involved. So you're charged that fee no matter what. So that is the value, that is the constant. You're charged it in no matter how much you drive, and then you add the per mile cost. So again, it does fit in with our initial beginning, certain words that we were looking for. We actually talked about flat fee. That's much more specific, but I see that a lot, so that's why it made the list of terms. So to recap, when you see, it's going to lead into today's episode also, because when you see an equation that's in slope-intercept form, you don't need to read and understand the whole problem, all right? I have nothing against reading. Reading is wonderful, and it's extremely, probably the most powerful skill that you could have in life. But on the SAT, in this specific situation, just reading this gets your brain going and trying to figure out what moving company is this, and the truck, and you're trying to figure out all this stuff, and it's all unnecessary, all right? What you need to do is look at the problem, be like, okay, this is slope-intercept form. All I care about, y-intercept, flat fee, and move on. You can do this problem in 5 seconds, possibly. All right, now to today's topic, literal equations. So you might ask yourself, what is a literal equation? It's an equation that has many different variables in it, and then your goal is to isolate one of the variables that's not already isolated. So you do a lot of rearranging, moving stuff from one side to the other. It's taught in Algebra 1, usually in the solving equations unit. And this one, we're actually just going to solve the problems the school way. So this one is not like the first 2 episodes. This is more like episode 3, where the shortcut is going to be in actually not reading the problem. So like I said earlier, reading is extremely important, but on these problems, your goal is to do it as quickly as possible. So I'm going to show you how you can kind of extract the information without reading it and getting hung up on what exactly they're talking about, because usually we read these and it's just confusing. So if you can avoid reading them, then you don't confuse your brain and you just go right to solving the problem. One thing is literal equations are a bunch of different variables. So you may think that if we go back to episode 2, where we picked our own values, these problems tend to have so many variables in them and that the school way is so much quicker that I really wouldn't apply that strategy to this one. So this is going to be basically the setup of the problem is going to be just like this one. So if we just want to jump into the opener problem, and then I can kind of explain this further. So this is from College Board Practice Test 1, Section 3, number 7. It gives us this equation, m equals the quantity r over 1,200 times the quantity 1 plus r over 1,200 to the nth power, all over the quantity 1 plus r over 1,200 to the nth power minus 1, and then that whole fraction times p. It says the formula above gives the monthly payment m needed to pay off a loan of p dollars at R% annual interest over n months. Which of the following gives p in terms of m, r, and n? So this is where, again, the way we're going to solve this problem is going to be just the school way. Right? I think if we look back to episode 2 where we pick our own values, then we would have to pick a value for, maybe n, they want it in terms of m, r, and n. So m, r, and n, and then solve for p. I think that would just be unnecessary work. So this is where it's really important to look at the problem and decide which strategy works best. So the strategy that we're really talking about today is just noticing an equation, all right? Also, compare this to episode 3. This equation is clearly not in slope-intercept form, so we wouldn't use that strategy where we're looking for keywords. What we're simply going to do here is just take this, give p in terms of, so that means we want to solve for p, all right? So we want to take this equation, and our goal is to isolate p. So we have to get this by itself. So we know this because we're given an equation, and honestly, we really don't even have to read the p. Just look at every answer. Every answer is solved for p. So that must be what we need to do. We don't have to have any understanding about paying off a loan or anything like that. All we have to do is take this equation and solve for p. So the key today, the shortcut, is to eliminate reading all of this in this specific type of problem. When you see an equation with a bunch of variables in it, and then every answer is an equation with a bunch of variables in it, that's all solved for the same variable. And that tells us that we can literally skip the entire paragraph and save a little bit of time. Now this one has, I like to show something else that's similar to this. So this one looks so complicated with all these r's and n's and everything. Let's just pretend that our equation was m equals 3 over 5p. This is like another little strategy. It's almost like a mini strategy that I like to use. We're not going to do a whole episode about it, but I will just mention it here. If something looks complicated, you can pick another example that's similar to it just to figure out what are the steps that I would go through in order to solve this problem, and then maybe find a way to apply that to a more difficult problem. So if you look at this problem, if I asked you to solve for p, to isolate p, I would need to get rid of this fraction 3/5. Well, the best way to get rid of a fraction is to multiply by its reciprocal. Because if I multiply this by 5/3, then 5 divided by 5 is 1, and 3 divided by 3 is 1. And that leaves us with just 1 over here, which is perfect because 1p is just p. So that gives us p on this side, which is what we're looking for. But if I multiply the right side by 5/3, I need to multiply the left side by 5/3. So essentially all I did to get p by itself was multiplied by the reciprocal of the fraction that was being multiplied by p. So let's try to apply this to this much more complicated version. Well, all this is right here is just a really fancy looking fraction. And my goal is to isolate p. So if all I do is multiply both sides by the reciprocal of this fraction, that's going to get p by itself. So if I multiply by the reciprocal of this fraction, it'll cancel out. So for the sake of, I don't really have a lot of room here, let's just say I multiply this side by this fraction and that goes away, just as if it did over here, the same exact concept. Then the other side just becomes the reciprocal of this fraction times n. So this is the denominator of the other side, and then over the numerator of the other side. And that is all times m, and that equals p. So now I have p by itself, and this is, I'm just illustrating exactly what we need to do, but this is a problem where I don't even think you need to do any work. If you just look at your answers, you're just looking for the answer that has the reciprocal of this fraction in it, and that is b. A has this exact fraction, and C and D, they got rid of a lot of the fraction, so they almost don't even make sense, right away. All right, now on to the second problem. So this one is College Board Practice Test 3, Section 4, number 13. This one, I'm going to just actually model exactly how you should be doing this problem. All right, so I've read problems in the past, but now let's really, really get into it and show you exactly how you want to do this problem. So you're sitting there on the test, and you get to this problem, and you see an equation, h equals negative 16t squared plus vt plus k. All right, so I see an equation, all right, and that should make you think, all right, this is back to either episode 3 or episode 4. Episode 3, the equation was in slope-intercept form. Well, this is definitely not in slope-intercept form. This is a quadratic because we see it raised to the second power. And then we say, okay, is there a bunch of variables in it? Well, yeah, there's h, there's t, there's v, there's k. And then look at your answers. Skip the paragraph and say, oh, all my answers are solved for v. So I already know what to do, so why would I need to read directions when I know exactly what to do? And we are just going to skip right to the work. So that little shortcut is the Your Friendly Math Tutor strategy that we're learning about today. But in order to actually solve this problem, we're just going to do what you learned in school. We're going to go back to Algebra 1, and we're going to write the equation. And again, without reading, I'm just going to look at my answer choices. They're all solved for v, so let's get v by itself. So the way that you want to get v by itself, so if we look, and v is what we're isolating. Since v is it's not in the denominator. If the variable is buried in the denominator, then you would want to move it out of there. But if it's not buried in the denominator, you don't want to move that. You want to keep it where it is. We want to move everything else around it. And let's start the furthest away from it. So either the negative 16t squared or the k. Both of them need to go to the other side. These are 3 separate terms. The way you move a term from one side to the other is you either add or subtract. So this is a negative 16t squared, so I'm going to simply add 16t squared. This is a positive k, so I'm going to subtract k. So I need to do this on this side, and notice on this side these go away, so I'm left with vt. But on the left side, none of these are like terms. So what I'm going to have to do is just rewrite them in that order. So let's say I do 16t squared plus h minus k. We could do this really in any order. It wouldn't be that big of a deal. And then I want to get v by itself. So now I have v times t. Well, the inverse of multiplication is division. So I'm going to divide by t, and then I have to divide by t here. So now I have isolated v. I go look at my answers, and I don't see that answer there. All right? So that does not mean we did this incorrectly. It means we need to keep going. All right? So what I would do is, you see how there's a t squared here and a t down here? We can simplify that, but we have to be very, very careful. I can't just simplify it from here. The h and the minus k also are divided by t. So I'm going to write this as 16t squared over t, because that's the one that I can simplify a t out of. And then I'm simply just going to write the h minus k is going to still be over t. So a common mistake I see a lot is to just cross out this t and then one of these, the square. But you can't do that because the h and the minus k have to also be divided by t, so that's why I need this here. And then this t is going to divide out with one of these t's, and then I'm going to go back, and answer D is the same thing, except it's in a different order, but we should know that addition is commutative, so therefore it's the exact same answer. All right, now to our third problem. This one is College Board Practice Test 6, Section 3, number 17. So again, let's continue with this, and let's model exactly how you would do this when you come up to this problem. So we see this problem, and it's hard to, it's talking about a bricklayer, but instead of reading through the problem and trying to figure out about this bricklayer and all the things about this problem and kind of get ourselves confused, let's just look and see if there's an equation that kind of sticks out. And I see one right here. So n equals 7LH. So this is an example of where you won't have an equation right away, but you got to be on the lookout, and you want to look when you see a paragraph. Before you read the whole thing, I want you to just look and skim real quick. Get good at oh, I noticed an equation, and just zoom in on that. All right, so now this is the equation. I don't really care about the rest of what's going on. I just look at my answers, and I have them all solved for L. And also, let's again review the fact that if this were in slope-intercept form, then we could use a similar strategy of not reading the entire paragraph, but this one's not in slope-intercept form. It is a literal equation because, again, we have multiple variables, so we end up with 3 variables, and every answer is solved for the variable L, as opposed to this one is solved for N. So that tells us exactly what to do. So my goal is to get L by itself. So the 7 and the H need to move to the other side. We do that. Well, this is 7 times L times H. So the inverse of multiplication is division. So I'm going to divide by 7 and H. Well, that H over H is 1. 7 over 7 is 1. So that leaves L on this side. All right? That was a weird looking L. So that leaves L over here. And then I'm going to, if I divide this side by 7H, I certainly got to divide this side by 7H. So N over 7H is L. So not really much to do. And I'm looking at my answers, and I see C. L equals N over 7H. So that must be my answer. All right, nice and simple. Not a lot of work to do. And again, the way that we're doing it is the school way. So I don't want these videos to come across as like school way versus your friendly math tutor way. No, you can do one, you can do the other, you can combine them. Here, the strategy is to just notice an equation, just notice all 4 answers are that equation, but rearranged for another variable, which is just what a literal equation actually is, and just go right to the problem. Just dive right in. The time it takes to do these steps over here is probably less than the time it would take for you to read these and then read every answer choice. So it is a huge time saver. We're trying to bank this time. as much as we can, so that when we have other problems, we have extra time for those problems, that all these strategies and shortcut little things aren't going to work on every problem, right? There's 58 problems on the test. You can't use 58 strategies, right? It's just not going to happen. So for those problems, we want to use these strategies so that we have more time for those problems to do the extra amount of math. And it's just going to give you a better opportunity to just earn as many points as possible. All right, now on to our closer problem. So look at this long problem. I needed 2 sheets of paper just to fit this. And my hope is that we don't need to read this whole problem, but I will just for now, just to kind of give you an idea of how long it actually does take to read these things, all right? So when designing a stairway, an architect can use the riser tread formula, 2h plus d equals 25, where h is the riser height in inches and d is the tread depth in inches. For any given stairway, the riser heights are the same and the tread depths are the same for all the steps in that stairway. The number of steps in a stairway is the number of its risers. For example, there are 5 steps in the stairway in the figure above. The total rise of a stairway is the sum of the riser heights as shown in the figure. Then we have this figure that we're all looking at. We're trying to make sense of all of it. And then we finally get to our question, which is, which of the following expresses the riser height in terms of the tread depth? So I will leave you to ponder that, and just what I really want you to think about is just how long it would take to read this, number one, and then when your brain is trying to make sense of this problem, and then you probably, without today's strategy, would most likely have to read it again. I know certainly it would take a couple reads to really figure out exactly what's going on, and then you have a diagram to try to figure out. So just think about how much time that would take, and then think about what we did today, and exactly the only piece of information that you really need. There's one really important piece of information in this problem, and then our answer choices, and that's all you need, right? All this other stuff is just kind of nonsense. It's not necessary. All right? All right, so to today's takeaways. So we were talking about literal equations, and just like episode 3 on slope-intercept form, both strategies began the same way. It was notice an equation, all right? You see a single equation either at the top or somewhere embedded in the problem. That's what you want to look for first. When you see a lot of words, see if you can see just one equation. If that equation is in slope-intercept form, then watch episode 3 and think about all the different keywords that we can use to just, figure out the answer. For literal equations, it's even easier than that. You don't even need to look for keywords. Just look at your answer choices, and all the answer choices will be solved for the same variable. And that'll tell you which variable to solve for. And you just rearrange and you isolate using what you know about algebra. So it works on a very specific type, but there are several problems like this on any SAT that you see. So it can be extremely, extremely time-saving, and that's really the whole point, is to look at the problem, go for the equation, rearrange the equation, and you have your problem and you move on. Now, it's also important to know when this strategy doesn't work. If it's not a literal equation and it's not specifically is something in slope-intercept form, then you may or may not have to read the problem. I would get into the habit of just skipping to the question if you have to, if it's not one of these types where you can ignore it. You already know the question because they're all solved for the same variable. So what you can do is just read the question, and then you may have to go back and look at specific things in the problem. There may be some problems where you have to read the whole thing, but that is why today's strategy is so incredibly important, is that when you have the opportunity to just skip an entire paragraph and just go right to the math and do the problem really quickly, you are now saving all this time on that problem that can then be applied to another problem where you may have to do a lot of reading and rereading and kind of figuring it out, or even just another problem that math is just difficult. And some of the strategies that I went over in episode 1 and 2 are ones that I'll go over later in this course don't apply. Because like I said earlier, they don't apply to all 58 problems, all right? So what we want to do is save the time where we can and then use that time on other problems where these strategies don't apply, all right? So that is it for episode 4. I really appreciate everybody watching. Please leave some comments or like the video, or you can subscribe to our YouTube channel if you haven't done that already. Check us out. We're on Instagram, we're on Facebook, we're on Twitter. And until next time, your friendly math tutor is out. All right, now to today's topic. No. Nope. To